Kia ora. Let's use this interactive to explore the boiling points of simple organic molecules, where we can change the functional group and see what happens when we increase the length of the chain. So we'll start with the alkane. So we'll click on a hydrogen. We're going to add a hydrogen to a methyl. So you can see we've got methane, and its boiling point is quite low, as you would expect, because it's a non-polar molecule and so has very weak temporary dipole forces of attraction. And if I have ethane, because the mass has increased, the chain has got a little bit longer, so those temporary dipole forces of attraction are getting a bit stronger, and therefore the boiling point is increasing because of that extra mass, extra length, and therefore stronger and stronger temporary dipole forces of attraction. If I now change this and I have an haloalkane, so I can choose between fluoro or chloro. So if I add now a fluorine, the mass increases a lot more, because fluorine has a much greater mass than hydrogen. And so you can see there's an increase, that it's nearly the same boiling point as ethane, even though it's a fluoro methane. And that's because there is an extra mass. It's now 34, and it is also a polar molecule, and therefore you would have also the permanent dipole forces of attraction. And as we click through this, you can see it follows a very similar pattern, always being just slightly ahead of the previous one. And that's because of, again, the polarity and the extra mass. Now you can see this effect very strongly when I have a chlorine, because the chlorine is a lot heavier. There are a lot more electrons, so therefore the temporary dipole forces of attraction would be a lot stronger. The permanent dipole would not be perhaps as strong as with the fluorine, because chlorine is not as electronegative as the fluorine. And if I click through this, you can see the effect of that heavy chlorine atom has increased the boiling point. Now we get to the hydroxyl groups and the amine, so the alcohol. If I now have methanol, we now bring in the third type of intermolecular force of attraction. We've got the temporary dipole as well as the permanent dipole, because it's a polar molecule. But because I've got a hydrogen bonded to a very electronegative atom like oxygen, then I can also have now hydrogen bonding holding the molecules together. And so you can see there's this sudden jump in terms of the boiling point. And you can see as my alkyl chain is increasing, the effect of that OH is not as strong, and you can see the graph gets a little bit flatter, even though it does steepen up a bit, but overall it does flatten out, and it'll eventually meet, and that it won't make much difference. The amine is similar, but the hydrogen bonding is not as strong, and therefore the boiling point is not as high. So have fun exploring. I've deliberately left out the isopropyl. Have fun seeing what effect that has. Kia ora.